This is a GATE question from 2021 Engineering Mathematics. Question says that let S be a set of all vectors of the form A times X such that A is a matrix of size 3 by 2 and X is a column vector of 2 elements, and if there is a vector in S which is a column vector with element minus 1, alpha and 1, then the value of alpha is, and the four options are given, a minus 4, b minus 2, c 2 and d 4. So what value of alpha will make this vector to lie in this set S, where the set consists of all the vectors which can be written in the form Ax. So to solve this, any vector will lie in this set if that vector can be written in the form A of x. So that means this should be consistent, that if I write Ax is equal to this vector, then this system should be consistent. So using this we can find the value of alpha, that for what value of alpha this system Ax is equal to b is consistent. For that we know that we can write an augmented matrix where the left hand side is the columns of A and right hand side will be the B or minus 1 alpha 1. So the columns of A are 2 minus 4, 1 1 and 1 minus 1, and on the right hand side we have a minus 1 alpha 1. So clearly this is the augmented matrix for the non-homogeneous system, and if it is consistent then the vector will lie in the S, otherwise it is not. To check consistency we can reduce it to a Echelon form. So maybe first, to make this row simpler, I can interchange row 1 and row 3, or you can directly take this as the pivot position and use it to make the lower values 0 to form a Echelon form. But to do it by making this element as 1, it is much easier, I guess. So let us interchange row 1 and row 3. So 1 minus 1 1, third row becomes first, second row remains second row, and first row becomes the third row. Okay. So the first pivot position is this. To form Echelon matrix we have to make these two elements exactly 0. So we use two operations, row 2 minus row 1 on row 2. So first row remains same. In second row we apply second row minus first row. So 1 minus 1 is 0, 1 minus of minus 1, so this becomes a plus of 2, and alpha minus 1, so last term becomes alpha minus 1. Similarly, to make this element 0 in the third row first position, we have to apply row operation row 3 minus 2 times row 1 on row 3. So we'll have 2 minus 2 0, minus 4 minus 2 times minus 1, so minus 4 plus 2 will be minus of 2, and minus 1 minus of 2 will be minus of 3. So first pivot position we already have, second row pivot position is this, so we can use it to make the element below as 0. So we apply another row operation here, which is row 3 plus row 2 on row 3, so that minus 2 plus 2 becomes 0. So this gives a matrix or system 1 minus 1 1 first row, second row is 0 2 alpha minus 1, and third row becomes 0 0, and adding third row to second row will make it alpha minus 3 minus 1, so alpha minus 4. So first row has a pivot position on the left hand side. For consistency, there should be no row of the form where left hand side all elements are 0 and right hand side element is a non-zero. Okay, that will make it a inconsistent system. Or the rank of the A and rank of K has to be same for consistency. If this element here is pivot, then we will have inconsistent system, and to have consistency this last element in the last row has to be exactly 0. So alpha minus 4 has to be 0, which means that alpha value must be 4 to make the system as consistent, and only for alpha value 4 the vector will belong to the set S. Okay, so clearly there is option D, and this option D of alpha 4 satisfies only for this value. This vector will be in the S, that means it will lie in the linear combination of these two vectors, which is obviously a plane because these two are independent vectors giving two pivot positions. So for alpha is equal to 4, the vector will lie in the set S. Okay, so answer for this question is D part, that alpha has to be 4.